Arduino libraries are like toolkits packed with pre-written code that simplify complex tasks. Instead of writing low-level code from scratch, you can use libraries to handle functions such as controlling displays, managing sensors, or communicating over networks. For example, the LiquidCrystal library lets you control an LCD screen with just a few lines of code, and the Wi-Fi library makes it easy to connect your board to the internet. Libraries handle all the behind-the-scenes complexity, allowing you to focus on the creative and logical side of your project. Using libraries not only saves time, but also reduces coding errors, especially when working with unfamiliar components. They are maintained and tested by the Arduino community and hardware manufacturers, so you get reliable functionality with minimal setup. By integrating libraries into your sketches, you expand what your Arduino can do, adding features that would otherwise be difficult or time-consuming to implement manually. It's a smart, scalable way to build more powerful and innovative projects. Arduino libraries are essential tools that make project development faster, easier, and more powerful. They offer pre-written code for commonly used features, eliminating the need to write complex logic from scratch. Whether you're working with an LCD display, reading values from a sensor, or enabling Wi-Fi communication, libraries handle the low-level details behind the scenes. For example, including the LiquidCrystal library lets you control a screen with just a few simple commands, while Wi-Fi.h can connect your board to a network without needing to understand the full networking stack. Libraries not only save time, but also help you avoid errors by relying on tested and documented code. They allow you to focus on your project's unique logic and design rather than rewriting common functions. Including libraries in your sketch is as easy as adding a single line. Include libraryname.h and opens up a world of advanced functionality. This modular approach expands what your Arduino can do, enabling more creative and efficient project development. Arduino boards use three main types of memory, each with a specific role in storing and handling data during operation. Flash memory is where your program code lives. It's non-volatile, meaning it retains information even when the power is off, like a long-term filing cabinet storing permanent instructions. Whenever you upload a sketch, it's written into this space. SRAM, static random access memory, is Arduino's temporary workspace. It holds variables, function calls, and active data while the program runs. However, it's volatile. Once the board is powered off or reset, everything in SRAM is wiped clean. Managing this space efficiently is crucial, especially on memory-limited boards like the Uno. EEPROM, electrically erasable, programmable, read-only memory, is a small, non-volatile area used to store data that should persist across reboots, like calibration values, saved settings, or user preferences. Think of it as a persistent notepad your Arduino can write to and read from, even after power is lost. Understanding how each memory type works helps you write efficient, stable, and reliable Arduino programs. Starting with Arduino is exciting, but knowing how to avoid common beginner mistakes can save you time and frustration. First, regularly save and verify your code. The Arduino IDE's verify button checks for syntax errors, helping you catch issues before uploading. It's like proofreading before hitting send. Next, keep an eye on SRAM usage. Overloading your Arduino with too many variables or large data structures can lead to crashes or unpredictable behavior. Use memory-efficient coding practices, especially on boards with limited RAM. When it comes to hardware, always double-check your wiring. A single misplaced jumper can prevent your project from working, or worse, damage components. Follow circuit diagrams carefully and use color-coded wires when possible. Lastly, get comfortable reading error messages in the Arduino IDE. These messages often point you directly to the problem, whether it's a missing semicolon, undefined variable, or failed upload. By being mindful of these common issues, you'll troubleshoot faster, build more confidently, and spend less time stuck and more time creating. Your Arduino journey doesn't happen in isolation. There's a global community of makers, educators, and developers ready to help and inspire. Engaging with platforms like the Arduino Forum and Stack Exchange gives you access to troubleshooting advice, creative project ideas, and real-time support from experienced users. Don't stop at forums. Dive into resources from trusted names like Adafruit and SparkFun, which offer step-by-step tutorials, wiring diagrams, and project guides for all skill levels. Also, make a habit of exploring the official Arduino documentation. It's packed with detailed explanations, sample code, and hardware guides that are invaluable as you level up. Most importantly, practice consistently. Start with small projects like blinking LEDs or reading button presses, then slowly expand into sensors, displays, and motor control. Experimentation helps you understand how things work and builds the confidence to tackle more complex systems. The more you code, build, and ask questions, the stronger your skills will become. Arduino is all about hands-on learning, so stay curious, stay connected, and keep building.